All right, today we're going to talk about a change of basis. And before we dive into vectors and matrices, let's go ahead and talk about a familiar example you may be able to get your hands on. So let's suppose we have 10 miles and we want to convert that to feet. So what we might do is you do some dimensional analysis, and we'll do 10 miles times the conversion factor, which just happens to be 5,280 feet for 1 mile. And then these miles are going to cancel, leaving us just with a simple multiplication, 10 times 5,280, which gives us 52,800 feet. So that's how many feet are in 10 miles. And what's really nice about this type of analysis is it kind of works both ways. So for example, if you start with 52,800 feet and you ask how many miles that is, you can run the same game. You can start with that 52,800 feet and multiply by the conversion factor. The only difference now is we're going to flip the conversion factor. Instead of being feet per mile, we're going to use miles per feet. And that's because we want these feet to cancel. So we're going to flip that conversion factor. There's 1 mile for 5,280 feet. And now when you do the multiplication, which now becomes a division, you get 52,800 feet divided by 5,280. And sure enough, you get 10 miles. And so what we want to do today is do the same idea, but instead of just having a single number with a single unit, we're going to have multiple numbers in a vector with perhaps multiple different units. So let's just go back to our example real quickly. So last time we had this example, we had on one side, we have bags of chips. And we had different sizes. We had different types. We had nacho cheese. And we had Cool Ranch. And we had Fritos. And on the other side, we also had them in party packs. So you can buy the chips in big boxes. So one box might have had just 50 nacho cheese. And another box might have had 25, 25, and 0. So that's just Doritos. And another one might have had 20 of each. And so, for example, last time we discovered that if you wanted to convert some quantity of chips, some quantity of bags, you could actually express that quantity of bags in terms of this. This is a basis for R3. And so any quantity of chips can be expressed in terms of these party packs if you allow for fractional or negative, meaning you have to owe or sell back that party pack. But if you allow for that, then any combinations of chips can be made using the party packs because this forms a basis for R3. And in contrast, just bags of chips, those form a basis too. You just specify how many of each bag. Each bag is its own individual unit. And so this also forms a basis for R3. And so what we want to be able to do is we want to be able to convert from one basis to another. If I give you some number of bags of chips, you want to be able to know what party packs to buy to get exactly that configuration of chips. Or conversely, if you have a certain number of party packs, exactly how many chips you have. So let's go through that first example first. If I give you some number of party packs, so maybe as a first example, suppose we have 3, 2, and 1. So this just means we're going to have this number of party packs. And this just says we have 3 of the first kind and 2 of the second kind, 2 of just the Doritos ones. And we also have 1 of this mixed bag. So we want to be able to express how many of each type of chips we have. We want to be able to express this is how many of each type of bag do we have. We want to be able to write this in some sense. We want to be able to write it as just in terms of bags. And so we can do this just by feel, right? We can just talk through it. Well, let's talk through how many nacho cheese do we have? Well, from the from just the nacho cheese. We have three of the big boxes of just the nacho cheese. And then we have 2 boxes that have mixed bags, but have 25 of the nacho cheese. And then we have 1 box that comes with 20 nacho cheese. So altogether, what number goes here? We should get 220. And we can do the same thing for the Cool Ranch. So the Cool Ranch, there's 0 that come in that 50 box. Or more precisely, we have 3 times 0. There's 3 boxes, but there's 0 Cool Ranch. Plus 2 times 25. You still get 25 Cool Ranch. And you get 1 times 20. So that last mix bag has 20 Cool Ranch still in it. And similarly for the Fritos, that mega box has no Fritos. That 25 box also has no Fritos, but it does have 120. So we're just talking through. If you have this number of party packs, exactly how many of which type of bag do you have? And we can add them all up. So it turns out you have 70 Cool Ranch and 20 Fritos. And so what we want to be able to do is talk about, okay, how do I convert from one thing to another? How do I convert from party packs to bags? Well, you may notice one thing that's kind of happening in disguise is this is really a matrix, right? This matrix, the amalgamation of this matrix right here, of these vectors, form a matrix, and it's hidden. There's the 50, 0, 0, there's the 25, 25, 0, and there's the 20, just like right here. And what's really happening is we're multiplying that matrix times a vector. And that vector happens to be 3, 2, 1. Oops. So if we multiply this vector times 3, 2, 1, and just emphasize this is party packs, you get the same thing in just bags. So why does this really work? This seems kind of magical. Why does this work? Well, what's really going on, in some sense, is we have a conversion factor, right? The conversion factor, much like the original example with feet and miles, says that, okay, we have, you can think of this matrix as measuring bags, the different types of party packs per the party packs. So for example, for the first party pack, you have 50, 0, 0 in bags of the different types of chips. For the first type of chip, you're going to have 25, 25, 0 for the second party pack, and you're going to have 20 and 20 and 20 for the last type. So this is really the conversion factor that we have just like before. And we're going to multiply this vector, these matrices by this. Now, you should be objecting slightly because we're dividing by a matrix, right? And of course, we can't divide by a matrix. But this same idea is what's going to hold. So instead of dividing by a matrix, what we're going to do is we're going to multiply by the inverse. And so we can convert this instead. We're going to convert this to something that looks like this. We're going to convert this. We're going to take the inverse of this and put it up here. So instead of this, what we're going to do is we're going to take 50, 0, 0, 25, 25, 0, and 20, 20, 20. And that's measured in bags. This one right here is happens to be the identity. That's going to happen a lot, actually. But it's the inverse of the identity. And the unit here is now party packs inverse, which is just 1 over party packs. And we're going to multiply this by 3, 2, 1 party pack. And now what's really nice is we can kind of see what happens. If we look at the dimensions, well, this is party pack, and this in some sense is 1 over party pack. And so altogether, we have that the number of bags that we get at the end is just formed by multiplying these matrices together. And we know that this identity, this is the identity inverse. So the identity inverse is just equal to the identity, which is the same thing as it just not existing. So altogether, the total number of bags that we have is just given by the multiplication, in fact, that we just did. And we got 220, 70, and 20. All right, so this is like a really nice way of thinking about how to convert from one thing to another. You can take the analysis that you do to convert units from one to another, just like we did here. And you can apply the same idea to change from one basis to another. Here, I just given a special name to these different bases, right? We called this basis bags and we called this basis party packs. But you can do the same type of analysis by just dividing one out in place for another. What's really nice about this is it helps us go backwards. So for example, if we want to get, if we start with this number of bags and we want to know, okay, how many party packs is that? Well, we know what the answer is. But now what we want to do is we want to kind of do the same analysis. We're going to literally take the same analysis as before, except now we're going to do it in reverse. We want to divide out by the bags. Okay, normally you don't want to divide by a matrix, but just because you're used to dividing this out in dimensional analysis, we're going to do this one more time. Right, so this says that for every one party pack of the nacho cheese, of the mega nacho cheese party pack, you have 50, 0, and 0. This one says that for every of the second party pack, you have 25 and 25. And for every one of the third party pack, you have 20 of each, and those are measured in under the bags or the bag spaces. All right, and we can go through the same analysis as before. So we can't divide by a matrix, but we can. This is actually the same thing as taking this times this matrix. But that's now an inverse. This is now bags inverted. This is party pack. We're going to multiply that by this matrix right here. And this is now just the identity. So this is now just going to cancel. This first one's just I. So it's the same thing as before. We don't actually need it. And so we get the conversion factor from getting from one to the other is just the inverse of this matrix. Now this may seem silly. Why did I go through all this trouble when it just is the inverse of the amalgamated matrix? Oh, keep in mind, the party pack is still there. So these are going to cancel, right? And what we get out is whatever pops out is the inverse. So what is that inverse? The inverse happens to be something that looks like this. I'm using a computer to do this, so I don't expect you to do this in your head, of course. So what happens here is you should get, when you multiply all this out, you'll end up getting 3, 2, and 1, and that's using the party pack basis. All right, so this is an easy way to change from one to another. Now, it may be silly that why do we go through all this process when it just ends up being the inverse of the amalgamated matrix, namely, right, this is just the amalgamated. We started with these vectors right here. Like, why are we going through all this work when this is often what you get? So those are the three vectors you get. We just put them together and take the inverse. Why are we going through the big deal? Well, one of the reasons that we do this is because it's not always the case you're changing to and from the standard. You're not always changing to the standard basis or not. So for example, suppose we have our party pack basis. So you have one party pack of chips, and that was our standard 50, 0, 0, 25, 25, and 0, and 20, 20, and 20. But maybe one time you go to the store, you have an alternative party pack, right? Instead of offering this 20, 20, 20, they've swapped it out for a giant Frito pack. And now you're like, well, how do I buy the configuration of chips that you really want? Oh, not 20, 20, 20. They've swapped this out for 0, 0, and 50. So now you have a different configuration of chips. You have to ask yourself, okay, how do I get the configuration of chips I want? When you're used to buying in one type of party pack, how do you change your purchase when you have a different one? So we have to change from one basis to another. That's not as clear as what to do. But we can do the same idea as before. For example, what we can do is we can convert from one to another and then back into the other. So for example, here, let's suppose we had 3, 2, and 1 of one party pack, of the original party pack. This is the original party pack. So we're buying all of these chips according to that. We want to get the same exact configuration of chips, but using this new party pack right here. So now instead of buying a mixed bag of 20, 20, 20, we have to now buy it in the alternative form. So how does this work? Well, one thing we can do is we can multiply this. We're going to apply the same idea as before, but we're going to do it in 2 steps. All right, so we're going to do this in 2 steps. And I'm going to use the fraction here, even though that's not kosher with matrices, just to help you understand what's going on. Right, so we know that we're going to change from party packs to bags, and then we're going to go from bags to the new party pack. So we want to go to bags first. So there's 50 bags in every one of the original party pack ones. There's 25, 25, and 0 for the second one. And there's 20, 20, and 20 for the third one. All right, and now we're going to convert those bags to the new one, the alternative party pack. All right, so we have 50 bags of the nacho cheese and still the first alternative pack one. We still have 25, 25, and 0 for the second alternative one, but now we have 0, 0, and 50 for the third one. And so now it's kind of clear what we're going to do. Now, there's some ambiguity as to what the order we should multiply these in, right? When we pull up the inverse beforehand, it was clear what to do. But one thing I should mention is if we care about the order, as soon as we want to convert, the first thing we should do is we should undo the party pack. So we should always multiply them in kind of this order right there. So what we're really going to do is we're going to take the party pack and we're going to multiply it by the inverse of this one. Oops, we're multiplying, that's not equals. And now that party pack is the inverse of the party pack times this matrix right here. We're converting it into bags. And then we're going to multiply it by the inverse of this matrix. That's to get rid of the bags. And then we're going to multiply it by the alternative one, which happens to just be the identity. And the reason we're doing it this way is because it's very clear why we're doing it in the order that we're doing it in. So every time we convert, we're going to undo the previous unit and then get the next unit. Undo the previous unit and get the next unit. So altogether, what do we get? Well, this is just the identity right here. And this one's the identity inverse, which is the identity. So these can kind of go away. And so what we're left with is and also keep in mind the units are going to cancel too. So the units we're going to left with are the alternative ones. But in the end, the multiplication that we do is really just the inverse of that matrix times that one. Right, so this is the conversion factor here. This is the conversion factor that goes from party packs to bags. And then the inverse of this goes from bags to the alternative. All right, and we're going to multiply this by the number of party packs we started with. All right, and it turns out that this matrix right here, right, I'm doing this again by computer. This inverse right here is just 150 minus 150, 1 over 25, 1 over 50. All right, so we're finally going to be able to answer the question, what should we get at the end? So if we multiply these two matrices together, we will end up getting 1, 0, minus 1, 0, 1, minus 1, and 0, 0, and 5 halves. So what this says, if we want to convert from one type to another, oh, that's backwards, hold on. That's not what that is. All right, you get something slightly different. You get 2/5. There we go, that sounds better. All right, so that's the conversion. So if you multiply these two matrices together, you get that guy. And so now we can figure out, okay, if you started with the original party packs of 3, 2, 1, what should you buy instead to get exactly the same number of chips? Well, under this new configuration, you'll end up getting, you will end up getting 2, 2, and 2/5 in the alternative. So what this says is if you get to the store and you discover they changed the party packs, you should buy 2 of the big nacho cheese, 2 of the mixed ones, and then you should beg and plead to only buy 2 and 2/5 of the new big Fritos ones. And this is just how you change from one basis to another. All of your change of bases matrices are going to look like the amalgamated matrix of the vectors, either the inverse or not. And you have to think through, is it the inverse or is it not? And that's why I would encourage you to kind of write this fraction. This fraction may seem somewhat silly, but the fraction is going to tell you, are you using the inverse or are you not?